So in this video, we'll look at the topic of related rates, and let's look at the given graph here. You have certain quantity Q as the y-axis, and you have the quantity time t in the x-axis. And now you see I'm giving you a graph for how the quantity Q is changing corresponding to the time t. And by rate of change of the quantity Q corresponding to t, it actually means that I want to look at the dq dt, which is the rate of change of the quantity q with respect to time t. So it's a concept of derivatives, right? You are differentiating the q as a function of time t, and that's going to be the first derivative. And it can be used for us to describe how the quantity q is changing corresponding to the time t. You see, for any point is fine. We can find the slope of the tangent at any point. Is essentially the rate of change we look at. And let's look at some examples. So please look at the current problem. Basically, I'm describing a circle where the radius keeps increasing. So the radius keep increasing at the rate 8 meters per minute. So I'm talking about the radius here. It keeps increasing all time. And of course, for a circle, if the radius increase, if the circular shape is unchanged, and we expect that the circle keeps getting bigger all the time, and the area obviously is also increasing. In this problem, we're trying to find fast is the area increasing at the moment when the radius is actually 20 meters. And let's formulate the problem as follows. First, the area of a circle is the same as pi r square, right? And please look at the quantity given. For example, when the radius is increasing at 8 meter per minute, mathematically, this rate is actually the same as saying that dr dt, right? So I'm saying that basically dr dt is the same as positive 8. This fact means that the radius is changing corresponding to time t at the rate 8, and the unit is meter per minute. And now let's look at the problem. You are asked to find how fast is the area increasing. This question mathematically is asking you to find um, the rate of change of area corresponding to time t. So mathematically, by the notation, this one is actually dA over d. And can you find dA dt based on this equation? The answer is yes, because you can differentiate with respect to time t for the equation. So the left side is obviously dA dt. How about the right hand side? Think about that. Now it's a function of radius r, right? It is not given in the form of function of t. It is not. So which means that when you differentiate this, maybe first of all you can differentiate it with respect to r. If you differentiate it with respect to r, pi is constant, which just stays there, and r squared becomes 2r. This one is the derivative r squared with respect to the variable r. And as those of you who are good with the chain rule, you could understand that I'm using a chain rule here because you see the left-hand side. I actually would like to differentiate both sides by variable t, but this answer is only the derivative of the function with respect to r, right? So I think there's a change of variable. The second factor attached to it by the chain rule is that it should be dr dt. And now the answer is pretty clear. You actually have an equation dA dt equals 2 pi r times dr dt. And we noted above that this one is positive 8. And the rate r is also given, right? The radius r is actually 20. So it means let's do this calculation together. And this one is actually 320 pi. And please note that the unit dA dt is the same as meter square per minute. And this value represent the rate of change for the area biggie corresponding to the time t, and it is also the rate of increase for the area A of the circle under the current circumstances. And let's look at one more example. So please look at the current example now. I give you the rate of change of a rectangle corresponding to the quantity of the base with respect to time t, and also the rate of change of height with respect to time t. And now I'm asking you the rate of change for the area of the rectangle, right? So let's try to do this problem together. First of all, let's fix the variables. For example, I can call b to be the base, and I can call the height be h, right? So now the area of the rectangle is the same as a equals base times h. And now, to find the rate of change of the area is the same as mathematically I'm asking you to find the a dt. So let's differentiate the equation with respect to t together. So the left-hand side is clear. It is what I want, the a dt. How about the right-hand side? You are differentiating it with respect to time t for two variables. You can think of them as product of b and h. To differentiate it, we can use the product rule. By the product rule, you're getting the right-hand side as this, and let's fill in the variables together. This is the rate of change for the base b, right? So which means this one is actually 2, and then the height is decreasing at 5. This one is actually the HDT. Because it is decreasing, we have to use -5 to represent that. That's the rate of change for the height, which is decreasing. Mathematically, we have to use a minus sign for that. And for the base, now the base is actually 11 meters. So it is 11, and the h is clear. The h is actually 15. And now let's do the calculation together. So it becomes 30 minus 55, which is minus 25, and the unit is going to be centimeters square per second now. And that's pretty much our answer to this problem, but please notice the negative sign. It essentially means that the area is decreasing because this is negative sign. So decreasing at 25 centimeter square per second.